Hello, this is the video progress report for Team 22, Large Load Interconnection. This is the team. My name is Christopher.
I'm Antonio.
I'm Abdulaziz.
I'm Abdullah.
Hello, my name is Chris. Our senior design project focuses on creating an educational tool that helps explain how power grid contingency analysis works, especially for large load data centers and other high demand facilities. With the rapid growth of AI and cloud computing, data centers are consuming unprecedented amounts of power, which sometimes approaches the demand of an entire city. There is currently a limited amount of practical tools that show how engineers actually test these events in real transmission planning studies. And our goal is to build a simplified power grid model that demonstrates how different outage scenarios affects power distribution and system limits.
During this phase, we focused on understanding how large load impact the bulk electric system. After researching transmission systems, interconnection procedures and reliability standards, we realized that the main issue is not the interconnection processes itself, but system reliability. We analyzed the TBL 001 standards and built a contingency matrix covering N-1, N-2, and N-1, sensors. We also developed test cases for large data centers to do RAID ramp-up behavior. For budget and schedule, we are in good shape. We have most required resources. Budget is not a concern. We are finalized our bill of materials, and we are currently on schedule.
This diagram shows a representation of our final objective. It will be a board that models a small transmission system connected to an Arduino system, includes 2 generators, a transmission line, and data center board. Buttons will allow us to run different contingency scenarios, and electronic components like digital displays and LEDs will show system metrics such as loading and power flow. This will help us visualize how the system responds during contingency events. Our progress so far directly supports this objective. Our research on transmission systems helped us identify the key elements to include the model. Our contingency analysis research helped define which scenarios to simulate.
I will now talk about the future work. The first action step is to plan out exactly how we want the final product to function, like what metrics and what elements, and then we can start prototyping, and while testing that, we can start designing and building the final version. The final demo will include our final product where people can run the system and we can explain what they're seeing with also our research behind us on a poster board.
Initially, the team's objective was to develop reliability-focused guidelines that expedite interconnection while protecting the bulk electric system. However, after some reassessment, the team decided to shift the project focus from deep technical analysis to creating an educational physical model of a transmission system that would demonstrate contingency events and load impacts through visual elements like LED indicators and meters. We now work on a plan to accommodate the new direction of our project scope with a clear and definitive goal. Thank you.
Thank you.